negative 2.58. Okay, so that's a deviation for the value of x equals 6. If I looked at a deviation for x equals 9, for x equals 9, our deviation would be 9 minus the 8.58, which would be a 0.42. Okay? So these deviations are just ways of measuring how far away values are from the center of our distribution, from the mean of our distribution. Now, deviations have some interesting properties that we'll look at, but one of the first things we can talk about in terms of our deviations is, again, remember, if we go back to this sort of balance beam interpretation of what the mean is, right? The mean is sort of the balancing point of our distribution. Okay? We have some data here. The mean tells us where our balancing is going to occur at. Right? So if this is x bar and the stuff up here above, these represent our data values. One thing that you notice, or one thing hopefully that you'll notice, is that if I take the deviations of all the things smaller, and I take the deviations of all the things above, if I add all of those deviations together, what do you think I get? Don't get the mean. Let's look at a simple example. Okay? Let's take an example. Let's have 5 data values, 3, 2, 6, 8, and 9. Okay? So, first thing we're going to do is we're going to find the average. We're going to find the mean of these 5 values. Okay? What's the mean of these 5 values? Well, is it 6? Not the median. Let's make sure we're not going to, it might be 6. I haven't done this ahead of time, so let's see here. 5, 11, 19, and 9 is 28. 26. I have my bad days too, don't worry. So our x bar, our mean, is the 28 over 5, which, if we calculate it as a decimal, 5.66. So there's our x bar. All right. Now what we're going to do is we're going to find the deviations for all 5 of these values. Okay, so I'm going to make a little table over here. Here's our x. This is our x minus x bar. And then in the end, I'm just going to add up all those things. All right? So over here, just list my values. And I can list them in whatever order I want. I'll just list them from least to greatest. Okay? And now I'll fill in the middle column. Okay? 2 minus 5.6.
Negative 4.
Or 2 minus 5.6.
3.6.
Negative 3.6. Okay. 3 minus 5.6. Negative 2.6. 6 minus 5.6. 8 minus 5.6. 2.4. And then 9 minus 5.6. Okay. Now, if I add up all the values in that middle column, what do I get? Add them all up, you should get 0. Okay. That's not a magic property that happens just with this collection of data. That's going to happen every time we do this. Okay? The reason is that, remember, the mean is the balance point. It's where all of these things sort of balance equally, because they're all the same distance from that mean. The overall distance all of those values are from the mean is the same. So the sum of all of our deviations is 0. Well, alright, so maybe this notion of the deviations is not going to be a very useful one. If all of these things add up to 0, I can't really use these to talk about how spread out my data is. Well, you're right. We can't use these to figure out what our sort of spread is. And the reason is because some of these are negative, some of them are positive. When we add them all together, then we can't cut. So let's try something different. Instead of just looking at their difference, let's calculate their difference, and then let's square that. So we're going to look at what happens when we take these distances, we square them, and then we add them all up. Why do we do that? We do it so that we can get positive values that will ultimately lead us to a good tool to measure how spread our data is. Okay? So if we square these things, and I brought my calculator to do that, because doing these in my head is not always convenient. But if we square all these values now, let's see, 3.6 squared, should get a 12.96 here. 2.6 squared. 2.6 squared. 6.76 there. 0.16. 2.4. 5.76. And 3.4. 11.56. Okay. I now have a bunch of positive numbers. When I add all these numbers up, I'm going to get something positive out. When I do that, what do I get? 96 plus 6.76, 0.16, 5.76, 11.56. Add all these up, I get 37.2. Okay. Right, it's a number. It's a positive number. In some way, I can maybe utilize that to talk about how spread out my data is. Well, let's sort of adjust this number a little bit more. Okay? This number right here tells me what happens if I take all of my differences and I square them. Okay? I don't really have a good understanding of what that means. That has not really demonstrated a lot of meaning to me. So what I'm going to do is instead of this 37.2, I'm going to take this value and I'm going to divide it by 1 less than the total number of values I have here. Why is it 1 less? People found that that's what they needed to divide by. Right? So if I take my 37.2 and I divide by 4, what I get out is 9.3. Double check that. Fairly certain that's right. Well, I'll come to the why we're dividing by 4 in just a minute. For now, it's because it works. It's this 4 here is 1 less than the number of data values I have. It's called the degrees of freedom. I only need to know 4 of these data values to figure out what the 5th one was. Because I know what the mean is, and if I have 4 of these, I can go back and figure out what the 5th one was. So I only need 1 less because that's sort of what's called the degrees of freedom. That's how many pieces of data I need to know in order to describe this whole set. Okay? So I divide by 4, I get 9.3. This 9.3, how can I use this? What can I interpret this 9.3 as? Well, this 9.3 is sort of the average distance, the average squared distance any of these values is from the mean. On the average, if I pick one of these at random, I subtract it from the mean and I square it. On the average, it's going to be about 9.3 units away from the mean. Okay, well, that's kind of crappy, but it's a way of measuring spread of data, right? It's the average squared distance a value is from the center. What are the units on something like that? Well, the units are whatever the units of my original data are squared. I don't really like that. That's not really a useful value for me. So I'll talk a moment about what this thing is called, and then we'll talk a little bit about why it's not entirely useful for us. The variance is what this value that we just calculated here is called. Notationally, there is a formula for it. It's called S squared, and the formula for it is I add up all of my deviations squared, and I divide by 1 less than the number of data values I have. This term, the variance, again, is just talking about the average squared distance any of my data values are from the mean. Units here are trouble. And since the units here were a problem, they said, okay, well, let's try to fix that problem. And to fix that problem, they said instead of talking about s squared, we'll talk about s. And s, to get to s from s squared, you have to take the square root of both sides. And so what you get is a formula that looks like this. It looks awful. It looks this ugly formula that calculates something for us. It does that. You'll do it one time in class or on a quiz, but I'll never ask you to do this on a test. I'll never ask you to memorize this formula and use it on a test, because that's just a computational thing. If I sat you down in a room with 50 numbers and a calculator and gave you as long as you wanted, you could do this. There's no reason I have to do that on a test, because I'm not looking to see whether or not you know how to calculate numbers in this class. That's not what I'm looking at. I'm looking at, do you understand what this thing is measuring, or how to use this thing? This new thing here is what is called the standard deviation. Okay? What it's measuring, what it's attempting to measure, is the average distance any typical value is from the mean. So this is trying to measure the average distance a value is from the center or mean of our distribution. Okay. Now, this standard deviation is a useful tool. It's utilized in statistics everywhere, and we need to make sure that we understand some of its properties. So let us talk a little bit about that. Let me sort of do a little bit of background here. The standard deviation this is the typical distance a data value is from the mean. All right? What can we say about this standard deviation?